In the last video, we talked about how to experiment poorly and what makes a bad experiment. This time we're going to talk about what makes a good experiment. The most important thing that you have to have in an experiment for it to be worth its weight is random assignment. Random assignment is the same thing to experiments that random sampling is to observational studies. You must have random assignment in order to make any generalizations at all. And in experiments, the generalizations are cause and effect. So in order to have any cause and effect, you have to be able to say that things were randomly assigned. So, what random assignment does is it balances out the effects of lurking variables. It is randomly assigning the experimental units to the treatments. And the idea is that if I use random assignment, I can say that, well, yes, maybe I have an extreme case in one group, but I'm likely to have the same kind of extreme case in another group as well, so that it balances out when I compare the two. Okay, methods for performing random assignment are the same as methods for performing random sampling. I can use the hat method. Write all of my subjects' names on a piece of papers, cut them apart, put them in a hat, mix it up, and draw them out. And the first however many I draw are in one treatment. The next however many are in another treatment, and so on. I can do the same thing with the random number table or the random number generator on the calculator. Okay, there are many ways to do it. Some ways, though, I have to be careful. You may think, well, if I only have 2 treatments, I can just have them flip a coin. And if it's heads, it's one treatment, and if it's tails, it's another. However, I have to be careful. That's fine if I don't mind that there are the different number of people in each group. Because the likelihood of me having 50 people flip a coin and 25 of them get heads and 25 of them get tails is very unlikely. And you may say, well, I can have them flip a coin until the first 25 people get heads, and then everyone else who hasn't flipped yet is in a tails group. Well, but that's not random assignment, because you are not giving the people who haven't flipped the coin a chance to randomly pick a group. You're assigning them a group based on however many people there are in the other group. And so that wouldn't be random assignment, because you're not giving them an equal opportunity to be in each group. Okay, so flipping a coin can be a way to do random assignment, but you have to be skeptical, okay, and you have to look at exactly how it's being performed. Okay, so let's look at this. Suppose you have a class of 30 students who volunteer to be subjects in the caffeine experiment. How would you randomly assign 15 students to each of the 2 treatments? Okay, I could do 30 slips of paper. Label 15 of them with A and 15 of them with B. Let A be the caffeine group and B be the non-caffeine group. And have each student pick a name out of a hat. Pick a letter out of a hat. Okay? That would be one way to do it. I could number the students 01 to 30 and use a random number generator. The first 15 numbers that I pick, those 15 students are in group A, and the other 15 are in group B. Okay? There are many ways to do it. It doesn't matter which way you pick as long as it results in a random assignment. But I will give you an AP tip. Okay, AP tip. People lose credit on the AP test for not describing how they assign the treatments. You need to be very specific. The actual scoring is sufficient detail. You must give sufficient detail for someone to recreate your process. So, things like, I wrote everyone's name down on a piece of paper, cut them into equal sizes, put them in a hat, mixed them up. The first 15 names I drew were in group A, the next 15 were in group B. Okay, sufficient detail. Don't just say, I'm going to randomly assign them. That does not cut it. So now the question is, what is a completely randomized design? A completely randomized design is the experiment equivalent of a simple random sample. Basically, you take all of your subjects and you take the treatments and you randomly assign every subject to a treatment. So in a completely randomized design, the treatments are simply randomly assigned. This is the most common type of experiment that we will be talking about, and it's the one that you will have to describe the most. And there are two ways to describe it, really. One, you can just describe it in words, and number two, you can describe it in a diagram. The diagram looks something like this. If we look at this example down here, a health organization wants to know if a low-carb or low-fat diet is more effective than long-term weight loss. So the organization decides to conduct an experiment to compare the two diet plans with a control group that has only provided a brochure about healthy eating. So we have 90 volunteers. Okay, outline a completely randomized design. We would start with our 90 volunteers, and then we would use some type of random assignment. For me to just say random assignment here in my diagram is not enough. I would need to, below my diagram, explain how I did my random assignment. So that would be something to the effect of, I put 90 slips of paper in a hat that were with 30 labeled A, 30 B, and 30 C. I mixed them all up, drew them out one at a time. The people who received a slip of paper with an A on it participated in a low carb diet. The people who got a slip of paper with labeled B got a low fat diet, and the people who drew a piece of paper out labeled C got the brochure for healthy eating. I would need to totally explain that process and not just say random assignment. So then I show how my groups are split up. So I end up with group 1 with 30 people in it who get the low carb diet. Group 2, and I might even say on there this is the A's. Group 2, which were the B's, had 30 people and they were the low fat group. And group 3 were the C's and they got the brochure. Okay, so then after I apply the treatment, I bring them all back together and compare the results. That is a completely randomized, each group assigned randomly, and then I compare them all. Completely randomized experiment. Okay, now we need to say something about this group 3, this brochure group. Okay, we need to talk about the brochure group. And what we need to say about the brochure group is that they are what is called a control group. Okay, a control group is one where you are doing a group with almost like a dummy treatment. They either don't have anything or they take a placebo or etc. It's to compare your treatments to basically better than doing nothing at all. Okay, so the purpose is to help compare your treatment to doing nothing or to the status quo. Okay, all experiments do not need a control group. If I'm comparing one thing to another thing, so for example, low carb and low fat diets, I don't need a control group because it will tell me which one is better, low carb or low fat. When I need a control group is if I want to show that it is better than doing nothing. So is low carb or low fat better than just eating healthy? Then I need the control group to show that it's better than eating healthy and not dieting. But again, if I only want to show which thing is better, aspirin or Tylenol, low carb, low fat, pens or pencils, okay, if I'm only looking to compare one thing to something else, then I don't need a control group. Okay, let's check out the check for understanding questions on page 240. Remember, you do these, pause the video, and then check your answers. Okay, so for number 1, I have 29 students. I randomly assign them. Below I state my method. For the sake of time, we won't do that, but hat method or random number generator, but I sufficiently describe my method. I'm going to put 15 in group 1, and in group 2 I'm going to put 14, and I could either go ahead and say what my treatments are, or I can make another place in my chart that says treatment 1 is small group and treatment 2 is alone. Then after the treatments are applied, I compare. Okay, number 2, one way is I could use the hat method, what we just talked about. Another is to say I could number the students from 01 to 29 and pick a line of random numbers, read off 2-digit numbers until I have 15 that are in my range. So those students would be in the small groups and the other students would go it alone, etc. Either one of those methods works. Okay, and the purpose of having a control group for number 3 is to compare it to the treatment group. So in this case, we are presuming that kids who are working alone are evaluating their own performances. So the ones who work alone are our control group because we're evaluating whether the small group work is actually better than the working alone. Okay, let's talk about some principles of experimental design. There are 3 important principles that we need to make sure we always cover: control, random assignment, replication. Those are the 3 big principles of experimental design. Okay, you need to know that control does not mean control group. Okay, we've just discussed that we don't always have to have a control group. These are not the same thing. This control means that I'm going to use a comparative design and do my best to make sure that the only difference between the groups is the treatment. If I can do this and make sure that the only difference between the groups is the treatments, if there is a difference in their results, then that means that the treatment must have been the reason for that difference. Comparative design, and the only difference between the groups is the treatments. Okay, the purpose of this is to prevent lurking variables from becoming confounding variables. So if you have done your experiment correctly, you should not have any confounding variables. The second principle of experimental design is random assignment. We've already covered that random assignment is the random assignment of subjects to treatments, but what's the purpose? And the purpose is to balance out any leftover lurking variables that we cannot control for. So the idea is that if you can't control for it in the control principle by making the only difference the treatments and by using a comparative, that random assignment will take care of everything else. So that maybe I cannot control what someone had to eat before they came to my experiment, but if I use random assignment, then I will probably assign someone who just ate right before or who hasn't eaten in a while to both groups to kind of balance out the effect. So to balance out lurking variables we cannot control for. The last principle is that it's called replication, and it's exactly what it sounds like. Doing something over and over and over and over. It doesn't matter if you're the one who does it repeatedly or if you have many, many people do it one time. The purpose of replication is to repeat, and the reason is the more times you do it, the easier it is to tell a difference between something happening randomly and it happening because of the treatment. So it's easier to detect a difference between your treatments. Okay, so let's talk about how our caffeine experiment incorporated each of those three principles, or how we can incorporate them. So for example, control. I want to make sure that the only difference between my groups are whether one has caffeine and one has not. So I want to make sure that I use Coke and caffeine-free regular Coke, because if I use Diet Coke for one, like Diet Coke and then caffeine-free Coke, or caffeine-free Coke and then caffeine-free Diet Coke, if I use the different types, then I don't know one would have sugar and one would not. So that would create a confounding variable, because then I would know if the difference is the caffeine or the sugar. So I want to use the same type of Coke. I want to make sure that they drink them at the same pace. I want to make sure that everyone does the same thing before we check our heart rates. I want to make sure that we all drink the same amount. All of those things that are making the groups as similar as possible are control. Random assignment. Okay, that helps even out the chances of any lurking variables that I can't control for, like your tolerance to caffeine, how much caffeine you've already had, if you have had anything to eat, etc. I also have to realize that this won't work perfectly. So when I am doing my analysis, I need to reference the fact that there are some things that I can't control for, and that I am hoping that random assignment will take care of all that. And replication, I would want to have many people do this as experiment so that I can compare the differences and have multiple differences to compare. I would not want to do this experiment just once. Okay, so those are the three principles of design. You need to know each of the three of them, and you need to know their purposes and how to use them.